Hello everyone, welcome to Physics online classes for class 11 students. Let us continue chapter 4 Motion in a Plane. Today we are going to study about the terms scalars and vectors. As we have studied in the previous class, the brief introduction regarding motion in a plane. Motion in a plane, it means two-dimensional motion. Here we can consider xy axis or yz or zx axis. If the object is moving in a two-dimensional, then we can call it as motion in a plane. We know that in the previous chapter, that is motion in a straight line, there you have studied the terms related to one-dimensional motion. For example, displacement, velocity, speed, acceleration, position, time interval. So these terms can be easily represented with the help of number line system. But in motion in a plane, number line method is not sufficient. It will not represent motion in a plane. So here we are going to use a new method or a new way which is called vector representation. So to understand vector representation, first we have to know what are scalars and what are vectors. So let us start the video lecture on scalars and vectors. Yes, let us start motion in a plane. So before going to understand the vector representation, first we have to know what are scalars and what are vectors. To start with the topic, let us revise some terms. You can observe weight, length, height, temperature, pressure. So these terms you can observe. For example, we can say that weight of a man is 50 kg. Height of the building, we can take 100 meter. Length of a rod, I can consider 2 centimeter. Pressure of a liquid, I can consider 10 kg per meter cube. Temperature, we can consider 100 degrees Celsius. You can observe all these examples before going to study about scalars and vectors. Weight 50 kg, height 100 meter, length 2 centimeter. Do you know what these quantities are called in physics? Yes, exactly. They are physical quantities. Then what do you mean by physical quantity? You have learnt about physical quantity and their types in chapter 2, that is units and measurement. Yes, what is physical quantity? A quantity that can be measured is called physical quantity. Right? So which quantity easily we can measure, then we are going to call it as physical quantity. Or measurable quantities. For example, you can consider length, mass, velocity, temperature, area, volume, density, and so on. So these are measurable quantity. You can observe length. Length of a rod, 2 centimeter, 10 meter. We can easily measure this quantity. Similarly, mass of an object, 1 kg. Velocity, 10 meter per second. Temperature, 100 degrees Celsius. Area, 2 meter square. So here, all these quantities we can easily measure. Measurable quantities are called physical quantities. Then, what is non-physical quantity? Yes, non-physical quantity is exactly opposite to what? Physical quantity. Then how to define non-physical quantity? A quantity that cannot be measured. That is called non-physical quantity. Yes, you can think about non-physical quantity. Give an example for non-physical quantity. The quantity where we cannot measure it. It is not possible to measure the quantity, so we are going to call it as non-physical quantity. So they are non-measurable quantities. For example, affection, love, angry, hungry, pain. So these are what? Non-measurable quantity. Is it possible to measure the affection? Is it possible to measure how much you are hungry? No, it is not possible to measure. So these are called non-physical quantity. Yes, now we can observe classifications of physical quantity. You already studied in chapter 2. You can remember there are two types of physical quantity, and they are fundamental quantity and derived quantity. Physical quantity can also be classified as, see here the classification of physical quantity: scalars, vectors. Remember, physical quantity is divided into two types, and they are fundamental quantity and derived quantity. About these two types you have studied in chapter 2, that is units and measurement. But physical quantity can also be classified as scalars and vectors. Scalars and vectors are the two types of physical quantity. Is it clear? Now, to understand about scalars and vectors, first let us understand about the terms magnitude and direction of a physical quantity. You can observe magnitude and direction. Let us first understand the term magnitude. Yes, what is magnitude? You can observe this picture here. Magnitude means countable or measurable. You know the game like bowling, and these are the pins. How many pins are there here? You can count 1, 2, 3, 4, 5, 6, 7, 8, 9. So easily we can count these pins. Totally there are 9 pins. If it is countable, if it is measurable, then we can say that this is a magnitude. Similarly, these are expressed in terms of a number and a specified unit. For example, 10 kg, 8 Newton. Here, 10 is what? A number. 10 is a number. And what is kg? Kg is a unit. We know that kg is the SI unit of mass. Mass is equal to 10 kg. 10 is a number, kg is a unit. Similarly, here 8 is a number, Newton is a unit. So what is magnitude? Magnitude means measurable, countable, or which can be expressed in terms of numbers and specified unit. So magnitude should have a number, and we have to express in terms of a specific unit. For example, I am going to measure length of the rod, 5 meter. What is the length of the rod? 5 meter. Easily we are going to measure the length. This is a magnitude. Is it clear? Now we can take another example, distance. Yes, what is distance? The path length followed by an object. Wherever the object is moving, the path length or the total length we have to consider, then we can call it as distance. Right? So here, let us understand a scalar quantity with an example. Is it clear? So what is a scalar quantity? To understand this term, we can take one example here. What is the distance between Cyber Towers and Kukatpalli? You can observe the map. Cyber Tower to Kukatpalli. So what is the distance between these two positions? So here distance, let us given 10 kilometer. Distance is how much? 10 kilometer. That is between Cyber Tower to Kukatpalli. Then what is 10? 10 is a number that is called magnitude. It is measurable. Then kilometer is a unit. So distance is 10 kilometer. So it is having a magnitude with specified unit. That means distance is a scalar quantity because it is having only magnitude, but there is no direction. To reach that Kukatpalli from Cyber Tower, we have so many ways, so many roads to reach Kukatpalli. I can travel through the train, or I can go by walk, or we can go by bus. There are so many ways to reach that position, final position. So wherever the object is moving, the total path length we have to consider. So it is having only number with the specified unit, but there is no direction. Right? Physical quantities which are completely specified by magnitude and a unit only. They are called as scalar quantity. Remember, here we are not going to speak about the direction. We did not speak about any direction here. Only we have to consider magnitude and a specified unit. Now we can understand vector quantity with one example. See here, again I am going to consider the map, but here instead of distance, we can consider displacement. Yes, what is distance? The path length followed by an object. There is no proper direction for the distance. Wherever the object is moving, the total length we can consider. But what is displacement? Displacement is the shortest distance between two position, 2 points. That is displacement. So here you can observe the map. What is the displacement between Cyber Tower to Kukatapalli? The answer is given 10 kilometer north. So here 10 is a number which is measurable. So we can call it as magnitude. Kilometer is a unit. It is a specified unit. North is what? Direction. So here we have to consider magnitude as well as direction. So physical quantities which are completely specified by magnitude, unit and direction, they are called as vector quantity. So here again you can observe the map. To reach this Kukatapalli from Cyber Tower, there are two ways we can consider. You can observe the blue arrow indicates displacement and the red arrow indicates distance. What is the difference between these two, blue arrow and red arrow? Blue arrow is shortest distance between two positions. What about red arrow? How it is moving? You can observe University of Hyderabad, the Raghavendra Colony, then Kukatapalli housing, Naga, then it will come back. So it takes a long way. So this is a distance. So here you can observe blue arrow, Cyber Tower to Kukatapalli. It is the shortest distance. So the shortest distance between two positions is called displacement. It is having a particular direction. So red arrow indicates a distance and blue arrow indicates displacement. So then how to define scalar quantity? A scalar quantity is a quantity that has only magnitude and has no specific direction in space. If that quantity is not having any specific direction, if it is having only magnitude, then we can call it as scalar quantity. Right? So, only magnitude. Situation where magnitude alone is sufficient. Right? So now only if it is having magnitude, then we are going to call it as scalar quantity. Yes, what is scalar quantity? A scalar quantity is a quantity that has only magnitude and has no specific direction in space. We are going to call it as a scalar. Remember, whenever the term comes scalar, you can remember only the one term, that is magnitude. It is having only magnitude, means it is having only number with unit. There is no direction. So we are going to call it as scalar quantity. For example, scalar quantity length. I am going to measure length of the rod. Is there any direction? I can measure from right to left or left to right. We can get the same answer. So this is a scalar quantity. I am going to consider second example, volume. Volume means what? Length into breadth into height. Whether we are going to consider any direction here, it is not necessary to consider direction. Only there is a value, only magnitude. So this is a scalar quantity. Third example, time. So what's the time now? We can say that now it is 10:45 a.m. 10:45 a.m. This is having only magnitude. Whether the time changes according to the direction. If I am going to change my position from north to south, whether 10:45 becomes 11:45? No. So time never changes. So here it is having only numerical value, that is magnitude. Next example, mass. Mass of the object. It is constant. 10 kg, 50 kg, 100 kg, 1 gram. So mass of the object is having only magnitude. There is no direction. According to the direction, its value never changes. Is it clear? So these are the some example for scalar quantity. Now second point, if that quantity has magnitude and a specific direction. Here the situation where magnitude and direction both are required. Is it clear? So then we are going to call that quantity as vector quantity. Is it clear? Yes. How to define a vector quantity? A vector quantity is a quantity that has both magnitude and direction in space. Is it clear? So now here you can observe magnitude and direction, both the terms you can concentrate here. Scalar quantity is having only magnitude, but vector quantity is having both magnitude and direction. We are going to call it as vector quantity. Then you can observe the example, velocity. Velocity, for example, I can take 5 meter per second. So whether it is a scalar quantity or vector quantity, it is a vector quantity because how to define velocity? Rate of change of displacement. Displacement is having magnitude as well as direction. In the previous example you have studied, we are moving from Cyber Tower to Kukatapalli. So there the distance is given 10 km north. This is what? Displacement. When displacement is a vector quantity, then velocity is also vector quantity because velocity is rate of change of displacement. Suppose if I am going to consider speed, speed is not a vector quantity because what is speed? Speed is rate of change of distance because distance is a scalar quantity. Then second example, force. Force 5 Newton. How to define force? Force is the product of mass and acceleration. You know the equation F equal to ma. Mass into acceleration. Acceleration means what? Rate of change of velocity. Velocity is a vector quantity. So acceleration is also vector quantity. Immediately force is also vector quantity. Then third example, displacement. Displacement is having both magnitude and direction because displacement is the shortest distance between any 2 points. Then torque. Torque is, it is also a type of force. Torque means twist. Twist means what here? It is a couple of force. For rotational motion, we are going to use a torque. You are going to study about this term in the chapter system of particle. So this is also vector quantity because it is also force. Is it clear? So these are the some example for vector quantity. Is it clear? So now let us revise what scalars and vector quantities are. Yes, if it is having only magnitude, then we can call it as scalar. Right? Then if there is magnitude as well as direction, magnitude plus direction, so we are going to call it as vector. Is it clear? The quantity, if it is having only magnitude, then we are going to call it as scalar quantity. If it is having both magnitude and direction, then we are going to call it as vector quantity. Now you can observe some differences between scalars and vectors. The first difference, scalars have only magnitude, but vectors have both magnitude as well as direction. Then second difference, scalar quantity, they obey ordinary laws of algebra. Ordinary law of algebra means we can consider a plus b whole square, a square plus b square plus 2ab. So ordinary laws of algebra is obeyed by scalar quantity. But for vector quantity, the ordinary laws of algebra are not obeyed. They do not obey ordinary laws of algebra. Then third difference, scalar quantity, they change if the magnitude changes. Is it clear? If the numerical value, the number changes, then scalar value also changes. But here, vector quantities can change either magnitude changes or direction changes or both changes. Right? If only there is a change in magnitude, or if both magnitude and direction changes, or if only direction changes, then the vector value also changes. Then last difference, scalar quantities are represented by the ordinary letters, but vector quantities are represented by bold faced letters or letters with arrow mark on them. For example, force is denoted by F. Force is a vector quantity, so we can write in a bold letter F. Or you can write arrow mark on this letter. So this indicates vector quantity, velocity. We have to write arrow mark on the top of that letter that indicates vector quantity. For example, we can consider torque. Torque is denoted by the symbol tau. We have to write arrow mark on them. That indicates vector quantity. These are the some differences between scalars and vectors. Is it clear? So in today's class, we learnt what are scalars, what are vectors with some examples, and also we studied differences between scalar and vector quantity. So in the next session, we can study how to represent vectors.